Now let's look at some interesting properties of objects, continuing our discussion on Python objects. This is about mutability. Let's see what this is. So mutable versus immutable. Mutability means that whether we can change something, right? Mutability means we can change. Immutable means we cannot change, right? So, so with respect to objects, what we mean by mutability is when you say an object is mutable, it means its value can change, right? And if the value that's when we create an object, it will have a value. We earlier mentioned that every object has three things. One of the things is the value. So certain objects, when it's created, so all objects will have value, but certain objects, the value that it gets when it's created will remain there with the modification or changing being not possible. So such an object is called immutable object, as shown here. Value cannot change means immutable. Value can change means mutable. Now, these are basically, when you say objects, these represent data, right? So what does this mean? What is the point of having these mutable and immutable objects? So this is something, some interesting properties are there. These have some use or some implications. Basically, the mutability, whether an object value can be changed or not, depends on the type with respect to Python. In Python, whether a particular object's value cannot be changed or not, or in other words, the mutability depends on its type. So for example, numbers means all numeric types, strings, tuples, and various other data structures like bytes and frozen set, which are built-in types, or we call built-in compound or composite types. These are some of the examples of immutable data types. So far, we have come across two, numbers and strings. So we will not worry about other things as of now. We just try to remember that, okay, numbers and strings, all numeric types, including int, float, complex, right? And strings are immutable. Others are also there, but we are going to consider at this moment only numbers and strings, right? Because those are the ones we have come across at this point. And what about mutable objects? We have mentioned a few of them already, but we haven't come across them yet. Out of those, we have listed here lists, dictionaries, sets, byte arrays, certain class instances, and so forth. Mutable, out of them, we will mostly work with lists in the near future. In next, we will not be discussing that much of lists, but I think there will be some examples today in this session also. But again, a little bit later, we will use lists quite a lot in various examples and discussions. Dictionaries to a limited extent, perhaps, but overall, I would say for this discussion, you can just remember that lists are mutable, while there are several others also. Okay. Right. So overall, what I'm saying is numbers, strings as important data types, immutable data types we'll remember, and lists is an example of mutable data types for our discussion purposes, right? And as I have already mentioned, we have seen only numbers and strings so far. We will discuss about lists, tuples, dictionaries later, right? But we will bring up at least one example, one or two examples here of lists as well for this discussion. Right, so let's look at this immutability of numbers. What does this mean, immutability? Okay, so here's I am showing you, like earlier, an interactive session with the Python shell, right? So we are giving certain Python statements as input to the Python shell. And in this occasion, and when you see this 3 greater than symbols, you know that, right? This is the Python shell we are working with. With the Python shell, we'll accept what we type and give it to the Python interpreter and get a result back and show it. If there's something to be displayed, it will be displayed. Now, in this particular situation, I have also numbered these lines with within square brackets some number. This is just for our reference. In case we need to refer to something, it's easier to have this number, right? It's not part of Python shell or anything, right? This is the number 1 here. So, so when we say b equals 97, it's simply accept it. So there's nothing we get as a response. So we get to the prompt again, and in that point, let's say we say c equals b. And again, so that is our second statement that we give as input. So we have just numbered it as 2. And does it say anything about it? No, we don't get any response. That's fine. Or sometimes, I mean, Python doesn't say anything. We give a statement or expression as input. Python doesn't say anything in return. So that is its nature. If it doesn't feel or if it doesn't need to display anything, it will not. Okay. Right. Now the third thing we do is we type C and hit enter. It will show 97. Now this time, if you do something like this with Python, a variable name, when you type its name and hit enter, it will show its value. And this response from Python, we show it in red color, right? 97, which is this something surprising? No, not really, because what we have done is here, okay, considering the objects, the discussion on objects, when we say b equals 97, what does it really mean with respect to objects? One thing we can maybe identify, or we can, although we may not still understand about objects fully, one thing we can guess is that, okay, there's an object, an integer object whose value is 97, which is set at the time of its creation, right? When you say b equals 97, an object, integer object is created with value being 97, and its name we assign here as b, a name or reference given as b. Now, when we say c equals b, that's where it's not yet clear. We will see what the meaning of that. But when we say c, it gives the value as 97. So what does this mean? Sometimes you may be wondering, okay, when we say c equals b, do we have another integer object? Because c is 97, does it mean c is referring to another object or the same object as this one? How do we find it out? We can find it out by using the id function. So we'll say id within parentheses as argument, we give b, and it gives a particular number. This is the identity of b. So this number, as we have earlier explained, just imagine that it's the address of this object, right, in memory. Now I would like to see what is the identity of c. And when I give that input id within bracket c, what does it give me? Okay, it gives the same, exactly the same thing like here. Now, when you type, I would actually recommend or strongly urge you to try the whole thing yourself as well. And when you say id b, you will not get exactly the same number. You will get some number, right? Some number. It's basically depending on the address of this object in your system, right? So that's that identity. So it need not be the same with what I get here. Okay, so I hope you understand that. Anyway, now what does this mean? These two things means actually when we say c equals b, has it created a new object? Not really. It has a single object whose value is 97. Then what about c and b? both C and B are names of the same object. One single object, we have two names or two references. C refers to that or B refers to that. Both. That is why we get the same address here for both B and C, or same identity for B and C. All right. That means it's here. There's a single object. Now let's try to do something, because we are talking about immutability, right? Now let me try B equals 98. What will happen, do you think? Now we say numbers are immutable. Now when I try to do B equals 98, what will actually happen? Well, if numbers are immutable, maybe one thing we can guess is that, okay, we are like saying B equals 98 as if we are trying to change the value of that object that B refers to. The current value is 97. Here, are we going to change it to 98? Then in that case, Python will complain or give an error message because saying it cannot change. Will that happen? Okay, we just try it out. You type B equals 98 and hit enter. What will happen? Well, it didn't give any error message. It didn't say anything. Simply, it seems like it accepted it. Or is that the case actually? Has Python simply ignored it? That can also be the case, right? You can guess, oh, well, we asked it to say, we tried to give the value 98 for that object, but it didn't say anything. Maybe that numbers are immutable, so maybe it just silently ignored what we said. Is that the case? So, okay, you can find out, right? So we say, okay, we'll check the value of B then. Let's say B. Wow, we get 98. So is that really possible? What does this mean? Now, this means, okay, B, the object that B refers to has a value 98. Or does it mean that its value, earlier value 98, 97, it has been changed to 98? Is that the case? Okay, how can we find out? All right, we can use the ID thing. And we can say, okay, let's check with C then. Because earlier B and C were referring to the same object by looking at this ID. That was what we concluded. Now let's see if B and C were referring to the same thing. What's the value of C? When you look at values, the value of C, it is still 97. So what is going on? What is going on? Okay, we can, then the next thing we need to do is basically actually see what is going on, see whether B and C still refer to the same object. Actually, here it means it cannot be the case. B is referring to an object whose value is 98, while C is referring to an object whose value is 97. That means actually there are two objects, it looks like, right? So we can find out by looking using the ID function again with B, gets a number which is different from the previous one now. Different from the previous one, right? And when I check the identity of C, what does it give me? It gives the original one still. So can we see what has happened? What has happened is when we say, okay, up to this point, on this side, we know B and C were both referring to a single object, integer object whose value is 97. Now, the moment we said B equals 98, it silently accepted it. But behind the scenes, what has really happened is Python has created a new object, new integer object whose value is 98. And B is now referring to that one. So the previous object did not change its value. It cannot be the case. We cannot change its value because numbers are immutable. But while numbers are being immutable, we also have to understand what's going on here. If you do something like this, earlier we referred to some object with B, and when you say B equals another thing, it is actually not changing the previous objects because it is a number, you cannot change its value. What actually happens is a new object is created and its value being 98, and B now refers to that. That's why B value 98 is shown here, and B's identity is shown as a different one, because that object that B refers to is a different object than the other object. Okay. So that's basically what happens there. So let's try to explain it a little bit further using some diagram representation. Right? When you say B equals 97 and ID being this value, what does this mean? You can visualize this. Okay, we have a memory location here, the address being this one, and its value being 97. So that is basically an integer object in this memory location, the value being 97. Now B refers to that. B is a name, or we say reference to that object. Okay, when you say B equals 97, that's what it means. Now, when I say C equals B, what happens is we give that same object another name. So C also refers to the same thing. Okay, that is why when you check the identity of C and B, they be both the same, right? Because they both refer to the same single object. Right, then let's go to the next one then. Now, when we say B equals 98, and we know that there is a new object whose identity is this. So that scenario can be visualized like this. Now, B refers to a new object whose identity is this and whose value is 98, whereas C still refers to the previous object because we didn't really change C, and whose address is as before. The identity, remember we mentioned that identity will also not change, right? So this is basically what the way we can explain what happened there. Now you can imagine then if you next say C equal 97, what will happen actually? Let's say if I say C equals 97, here let's say if I say next prompt, I will say C equals 97. What will happen? Then, of course, sorry, not C equals 97. Sorry, I made a mistake there. So not C equals 97, maybe 99, right? I would say C equals 99. What will happen? Then, actually, what will happen is we will get a new object 99, and C no longer will be here. C will be now referring to this one, and this will have some address here, right? So this is what will happen. Now, what about the object 97? Is it still there? If you do these things, if you say C equals 99, we said the C will now refer to that new object 99, right? A new object will be created with value being 99. Now, what about this object 97? Is it still there? Yes, it is still there, most likely. Right? But do we have access to that object? No, we don't have access, because access to objects or data is through variables, so what we call names. So when C is now referring to 99, earlier object 97 doesn't have any reference. If you haven't done so, right, then 97 is simply there without any variable for us to access it. Now, in the program, we will be sometimes doing lots of these kinds of things, right? At one moment, maybe you are in a loop, iteration going hundreds or thousands of times, and within the loop, every time, let's say we say C equals something. Then you can imagine maybe the previous object that C was referring to simply doesn't have any reference, and C will be referring to a new object. So it may be done hundreds and thousands of times in a loop. Then what we are saying is we are getting objects like this, every iteration of the loop, some data in the system, in the memory, without any access. So we keep doing this thing. What will happen? There will be lots and lots of data or objects with no reference at all. Now, with no reference at all means what? I mean, we can't do anything about it as a programmer. We don't have access. So it's basically useless data, right? Useless data hanging around in the memory, simply spread out in various places in memory. So in a Python runtime environment, in the execution environment, This is quite possible. Various data objects, they are with no access, no reference, right? Useless, basically. So what do you call these useless things? I mean, sometimes in our homes or wherever, or at our workplace or school or university, when we have useless things, what do? We throw them away. I mean, we call them what? Garbage, right? We call them garbage, right? So here you can refer to this such data with actually no use at all, but still they were created at one point. Now they are of no use. That's garbage. So garbage is something that can be there. When you say garbage here, it means data that has been used before but no longer useful, right? Nobody uses it. Nobody refers to that. So we get garbage piled up, garbage collected in the system as we proceed in a program being executed. So do we have to worry? Are we concerned about it as a programmer? Well, no, programmers don't have to worry. Why? Because the Python execution environment will take care of that. Garbage will be collected by the execution environment, right? And we don't have to worry, right? That is basically one, maybe a convenience that we have as programmers. The system will look after these things, and from time to time, not continuously, not frequently, but from time to time, actually the system will look into we'll have some idea of, okay, the objects have been created and there may be certain garbage. So it will go and, retrieve everything, maybe remove all the data and reclaim that memory areas for it to be used, for it to use later on for other variables, other data, other objects. Right? From time to time, it will do it. Okay, that is additional information that I basically mentioned just in case if you're wondering what might happen if you keep doing these kinds of things. Okay. So garbage collection is actually in Java also, this is a similar thing. Java programmers also can, to a great extent, rely on the system garbage collector and not worry too much about memory being, allocated and not later on, no references for such data. Garbage collection is done by the system, right? Which is generally not the case with the C language, C programming environment, where a programmer has responsibility to manage the memory, right? So this is, remember one thing the previous lecture we said in Python we have automatic memory management. So this is what we mean, partly about this automatic garbage collection, and programmer doesn't have to worry about that. Okay. All right. So let's proceed. Right. So I have some other thing to erase also. Let's continue our discussion. So this is about immutability of strings, right? We talked about integers. So here's some explanation demonstration. Okay, let's say A, as we earlier said, A is a variable that refers to a string object whose value is A, B, C, X, Y, Z. Now, let's say we check identity of A, it gives us a particular number, right? So actually, you might be wondering, how can you get the one particular number like this? What does it mean to be an identity of a particular string? Strings are different from integers. Integers, maybe you can imagine like a single thing, whereas string is a collection of characters like this. So when you say the address or identity like this, what does it mean? Okay, for now, don't worry about it too much. Just imagine that internally Python has a way of keeping track of a string, particularly internal structure. So that structure has this address. You can actually go and check individual elements of the string, A, B, C, like that, individually. You might be able to do that. You might get different values. So for now, don't worry. Overall, the structure has this particular address. That's what it means simply, right? And we'll say S equals A, and then we check the identity of S. And predictably, I mean, based on our previous experience, we imagine that when you say S equals A, it's actually just no new object created. Simply S is referring to the same object like A, because its identity is the same thing. Because S and A now both refer to the same string object. And when I say A2, what does it really mean? A and square bracket A. Now, this is a special notation with strings that we can use. What it means is that a string can be visualized as a set of locations, right? So let me draw it here. So S can be visualized as a set of locations. And locations have numbers, so we call indexes starting from index 0. It's not 1, right? Remember, then next one has index 1 or location number 2, 1, and next one location number 2, next one location number 3, like that. We use, instead of location number, we normally say it's an index, right? And according to this particular string, so A is in location 0 or index 0, B is here, C is at index 2, X as index 3, and Y at index 4, and Z at index 5. So this whole string has a length of 6. You will learn more about strings later on. This is just to explain its immutability with this example. But because we have this notation, I just wanted to explain that. So when you say A square bracket 2, what do you get? It gets C. That is because you can see in the index number 2 or location 2, the value, the character C is there. So it is displayed this, when you say within quotation C, it simply means, of course, it's a single character C, but even a single character thing is a string in Python. So this basically says that it is a string that consists of just character C, because at the location or index number 2, that's what you have. So this is a way of accessing individual. In a string, you can access individual characters using the index notation. You use the name of the string and then a square bracket. Inside that, you give a number, right? So number should be a valid number. So what are the valid numbers for this string? 0, 1, 2, 3, 4, up to 5. Right? Only up to 5 that will have valid, because after that, the string is no longer there. It has no meaning. If you say S or A and within square bracket, if you say 6 or 7, it doesn't make sense, right? There's no such element at index 6 or 7. All right. The last index with the correct, that correctly you can refer to is index 5. Okay, so when you say A2, it basically shows that the character which is stored there. Right. So then let's see what happens. Continue. Here's an example situation where we can use the operator called is. So what is an operator? Operator means now plus, minus, these are also operators, which means we have operands. So if you say 9 plus 5, we say 9 and 5 are operands, and this plus is an operator. So that is a plus or addition operator, right? So I think that part you understand, operator. So similarly, even is an operator, because the two things on left and right of that operator are operands. So what this operator does is it's actually checking. When you say A is S, it's checking whether their identities are same or not. If they are the same, it will say true. So is operator is actually checking the identities of the two operands on the either side. And if they are the same, it will say true, otherwise it will say false. So it's not surprising that it says true here, because we know A and S refer to the same object, right? Okay, let's continue. Now I say S equals PQR. So S is referring to PQR. So what would happen here? Again, based on our previous discussion with respect to integer, maybe if you don't remember exactly what it means, maybe one possible explanation, which may be not correct or not correct, is that, okay, now S is referring to PQR, And is it that now we are changing the value of the object that is earlier used to be ABC, XYZ? Will Python complain? Actually, Python didn't complain. So I just want to check whether S is actually changed into PQR now. Whether, because as earlier we were discussing whether Python silently ignored this or whether actually accepted it. So when I type S, oh, we see that it's PQR. That means actually S is now referring to an object whose value is PQR. So does it mean it has changed the previous object? Well, we are talking about this immutability of strings. So just like the immutability of integers or numbers, here also something else is going on, right? We cannot expect the original object to change its value because strings cannot change its value. So then to make sure we check ID, and what do we see here? You can see its value is different from the ID of earlier ID value of S. So that means the earlier ID of A. It's different. And that means basically the same thing that we saw with integers, right? So therefore it's, I think you can understand what has happened is when you say S equals PQR, now a new string object has been created with value being PQR, and S is referring to that one now, that new object, right? So that's like similar to what we saw in the integer case. That's what it proves here, a different identity. Now, okay, maybe we can stop there and say that, okay, the same explanation like integers, that, okay, this is what we see, and with the strings, and maybe it indicates that strings are, yes, indeed immutable, because it doesn't allow us to change the string. Unlike in Python integers, here we can try one more thing to see whether another go at it, right? To see whether we can change the string. What can we try? Okay, something like this. It is not possible doesn't with the integer, because integers doesn't have anything like this, right? Here we are saying, okay, what does this mean? Here we are trying to set the value of at the fourth index of this string A, right? String A, remember, it is basically A, B, C, X, Y, Z, right? I earlier had drawn this thing. So it would have been something like this, A, B, C, X, Y, Z, right? 0, 1, 2, 3, 4, 5. So here we are talking about this particular value. At the fourth index, currently it is Y. Here we are trying to see whether we can change that, right? Replace Y by W. Just to try to see whether we can actually change the string. Then what do you get here? Wow, right? You can see it's a error message. And let me erase this one so that you can see the error message well. What does it tell? Okay, it says, okay, it has this particular error. It refers to this particular line and says type error, str object does not support item assignment, right? So this is basically in another way saying that strings are immutable. So in a string object, it says you are not allowed to assign items like this. So simply confirming that strings are immutable, right? So I hope that clears it. All right, so immutability of strings. Okay, then let's move forward. Okay, this is I just highlighted what the error is. Okay, now you mentioned earlier that, okay, while numbers, strings, and several others are immutable, we listed a few others as mutable. And we said numbers, strings, and other things as immutable, but lists as an example of a mutable data type, right? Now here we haven't covered anything about lists, so don't worry if this is confusing. You will learn more about lists later. But here the idea is to check or demonstrate the mutability of lists. So here's one way of creating a list, right? X equals and within square bracket with a comma separated list of things, right? So 3 is integer, 4 is integer, and we know MNO is a string. So in Python, this is quite normal. Python allows us to create a list of mixed kind of types, which is fairly rare in programming languages, right? In C or Java, things like that. We cannot create what we call arrays. Normally, arrays means arrays of same data type, right? The counterpart of list in those languages would be arrays. So arrays cannot actually mix various data types. It has to be one fixed type, right? So therefore, in Python, you can do this. So we have a list of 3 objects, that means 2 integers and a string. Now, one thing I would like to say in strings also, just like in strings, in lists also, we have the index notation. So, for example, this 3 has an index of 0. This 4 has index of 1, and MNO has index of 2 in the list. In this list X, 0's index means the value 3, index 1 means value 4, index 2 means a string MNO. Now, in that string, which is at index 2 of that list, within that string, you can also again index and access individual characters. I have already explained that something like that, so don't worry about it. Anyway, now here we are trying to show that different behavior, mutable behavior of list. So when you say X, it shows like that. That's fine. It simply shows its values. And then we say Y equals X. And you know what happens here, right? Y is generally, when we say Y, it shows the same content, right? Then you can check Y is X. It says true. So simply, it's a similar behavior as we saw with the integers and strings. What is that? When you say Y equals X, it doesn't create a new object. Y and X both refer to the same list object here. That is why Y is X is true here. They both have the same identity. That means they both Y and X refer to the same object, right? One single object whose elements are 3, 4, and Mn. Right. Now I just check the identity of X. It gives me a number. And I check the identity of Y. It gives the same number, obviously, right? Now, I try to do something like this. That is, currently in that location, we have 4, right? This is the index 1. Currently, we have 4 there. What we are trying to do here is that to change that value at index 1 to be JK. Currently, it has 4. Now we are trying to change into JK. Now, we tried this earlier with a string and we saw what happened. It didn't allow it. You say a message and that's it, right? Because it says, no, you cannot change simply because strings are immutable. Now, with the list, we try this. What do we get? Well, it didn't complain. Okay, didn't complain. So does it mean that it accepted? Well, we can find out. First thing is we are checking whether X is still Y. X and Y are the same. Yes, it says they are true. Both being the same thing. Then we can check what is the value of Y. What does it tell us? And see Y is referring to a list object whose first thing is 3, next one is JK, and next one is Mn. So what does this mean? It means this 4 actually got changed. And now by doing this thing, this has succeeded. Right? It has allowed Python has allowed us to change the value at the index 1 to be jk. And y still is referring to that. So why, when you do that thing, Python didn't create a new object because simply lists are mutable. Lists are allowed. Python allows us to change the individual elements of list. So it didn't simply go and create a new object. Only the existing object value got changed, and y still refers to the same thing. Therefore, that is why when you say y, it gives the value which is with the modified value, it shows like that. All right. Okay. So I hope we understood the mutability of lists also in this manner. Right. We are not going to discuss about lists anymore in this discussion. I just want to bring it up here to explain this mutability. Okay. You will learn quite a lot and use lists later on, because lists is a very useful data structure to do so many things. All right, let's proceed. So here's an exercise for you. Right, this exercise is not in the notes, right? So therefore you will see certain things, while in certain cases some extra description may be there in the notes, but there may be certain things which are not that much described there. We might describe more in the case of lectures, right? So here's an exercise which is not in your notes. Explain the following, right? We say a equals 9 and b equals 9, right? So first you say a equals 9. Immediately after that, we say b equals 9 to the Python shell. And we check the identity of a, it gives us some number. And I check the identity of b. What do you expect? Now it's not, earlier we said b equals 97 and c equals b, we said. Now here we don't, we say a equals 9 and we don't say b equals a. We say b equals 9. So generally speaking, you might expect, okay, there's one object here with the value being 9 and a is referred to that. Okay, when you do this thing, another object will be created and b is referred to that, right? Although both have the same value, right? So identity of a is this, and identity of b, what do you get? Exactly the same thing, right? You can see they are basically the same. So how can that be? Can it be? Can you explain that? Right. Let's take another example here. Similar thing. You say x equals ABCD, then y equals the same thing. And when you say x is y, it says true. Now, with the examples we have seen earlier, can we explain this situation with respect to the integer as well as string? Because you would normally expect this, in this case, a equals 9, b equals 9, that there will be two objects and therefore the identity should be different. Same here for the strings also, right? But somehow they both actually, x and y here, both refer to a single object. That's why you get true here. Here also a and b actually refers to a single object whose value should be here 9. So how can that happen? Okay, while you can try it yourself, right? And see whether you can try to come up with some explanation how this happens. Actually, I would recommend you to do this also. Let's, okay, this is a small value, right? Try increasing the value of this value here. Let's say at next time you try a equals 100, b equals 100, and see you will get the same thing. And next, say a equals 200, b equals 200, and see whether you get the same thing, same result. IDs being the same. Keep increasing, and you will find something interesting. Later, when a and b, the value is large, you will realize that actually the values are different here. The identity will be different. The same with strings also. I guess you can try with long strings, right? Long strings, maybe increase the length of the strings and see Up to some point, you will realize that, okay, their identities are same. You get the true value here. But when you, at certain points, you will see that on certain strings, it will be different. And just try to identify what kind of strings give this the false result, or what kind of integer values give these identities different. Okay, that's your exercise. And you can talk about it in our interactive session, perhaps, or whatever, maybe the forum, that's also possible, right? Okay, that's your exercise 1. Exercise 2. What do the following built-in functions do? It's just an exercise for you to find out. We have so far come across some built-in functions. When you say built-in functions, what does that mean? Built-in functions mean this is provided by Python, built-in. Why do we say that? It is coming as available for us. It's already there within Python, right? Because we can also define our own functions. We will discuss about it later, right? Any programming languages, the language would have that kind of functionality that allows programmers to define their own functions, so we call subroutines. But at the same time, they also come with built-in functions. So here are some example built-in functions. What do they do? Find out, right? What int, float, complex they mean. What is str? What is chrord? These are also useful for some occasions. Find what they are. X, oct, bin. Right? Find out what they are. That's a homework exercise. All right. With that, we end the part 2 of lecture number 2.